Hi everybody, welcome back to the Joy of Coding at Portland State University. This course is all about writing code that not only solves today's problems, but is robust enough to evolve to meet future needs as they are discovered. Managing source code as it evolves is a fundamental aspect of building solid software. In this slide deck, we're going to learn about the source code management tools that come with Git and how they can be used to store code and evolve it as it changes over time, and also how it can be used to allow more and more people to contribute to the codebase. So we'll begin with a general discussion of managing source code, why we need it, sort of what some of the fundamental concepts are. Then we'll dive into the Git tool. We'll see a number of the commands that it has and a lot of the things that you can do with Git to manage software that's under development. Beyond the basic adding new files to a repository and committing them, we'll learn about tagging, branching, and merging, and more advanced concepts and workflows. Essentially, every piece of software it has source code. These are the instructions that the developer provides to the computer to implement what the source code does. And so source code is a very important thing for developers, and there are a lot of things that we want from our source code. We want to be able to make changes to it confidently. We want to understand how the source code has changed over time. We want to make sure we don't lose our changes, so we want to back up source code in case something goes wrong. And we want to be able to change our source code. So for instance, working on new features while maintaining older features. And we want to work with others on our source code. We want to share the things that we've changed with others, and we want to receive the changes that others have made so that we can integrate them into ours. And also, we want to make sure that when someone else makes a change, that it doesn't conflict with the code that we've written. Managing source code is not a new problem. It's been around basically since people started writing software. But the tools that we have evolved to really meet the needs of today's developers. Things started out with just simple backup and restore capabilities on the local file system. You take a backup of your code, and if you make a mistake or accidentally delete a bunch of things, you can just restore it from that backup. As more people started working on shared code bases, the source code management tools, the SCM tools, offered centralized repositories where multiple people can contribute to it. And one of the most important features of these tools was the ability to detect and then resolve when multiple changes conflict with each other. Two people change the same line in the same file, for instance. This used to be a cause of a lot of problems with software. People would overwrite each other's changes, or you'd end up with code that doesn't compile because it was changed in incompatible ways. And the tools helped detect that and then resolved it so that the right thing happened. Code management systems also allowed you to create a branch of a code that allowed one developer or group of developers to work independently of others on isolated code lines until they were ready to then merge or introduce those changes into the primary code line. As software development became more distributed and people all over the world were working asynchronously on shared code repositories, the SCM tools grew to offer capabilities to allow code to move easily between different machines and different systems. And then finally, what we've started to see in the last few years is that the source code management tools also offer collaboration capabilities for multiple people to not only manage their code, but have discussions about their code, to propose changes, and have a discussion about the changes that they want to introduce into the system. There have been a lot of tools that aim to solve these problems. Today, Git has really emerged as the de facto tool for doing SCM. Yes, there are other alternatives still out there, but I think it's fair to say the vast majority of developers use Git to manage their source code. Git provides command line utility for all major operating systems. Git is free and open source and actually was developed by Linus Torvalds, who developed the initial Linux operating system. In Git, you manage what are called repositories of files that are under version control. And we'll talk about exactly what that means in a couple more slides. I think one of the reasons that Git has become so popular is that it has really good support for working distributedly, to having code repositories that live in multiple places all around the world, and Git makes it pretty easy to move changes from one repository to another. If you'd like to learn more about Git or get these tools, go to the primary Git website, git-scm.com. Where we stand today, developing code solely in the cloud using cloud-only tools is still evolving. The vast majority of software is still developed on somebody's local machine and then shared with others. And this is the primary use case that Git seeks to fulfill. So again, when you want to manage code with Git, you create what's called a repository that can store any file. It doesn't have to be source code. Most of the files probably are source code, but it can manage any file that's placed in this repository. And as you and others make changes to the source code, what you do is you create new what are called versions or revisions of that code in the repository. And what Git does, it takes care of all the bookkeeping of who has changed what when and what things change. And as we'll see, when multiple people make changes, Git is really good at weaving all those changes together into something which is sensible. Because Git takes care of all this bookkeeping, what you end up with is this history of all the changes. And you can essentially go back in time and look at earlier revisions to the repository to see what your code looked like in the past. We can also work with code that began in the past by us creating what's called a branch, and we'll see what branches are in a little while. Now, to get started with a Git repository, you can create it using the git space init command. This will create a new repository in whatever directory you run the command in. As you can see there, when you say git init on the command line, the Git tool will issue a little message telling you that yes, it created an empty repository in .git. Now the .git directory contains basically the internal database and bookkeeping information that Git uses to manage the files that are under source control. So if you go look at that .git directory, you'll see there's a bunch of stuff there. It's not anything that you really need to worry about, and actually something you shouldn't mess with. It's all the internal guts of Git, but it's good to know that it exists. After you've created your Git repository, you can start adding source code that is under management by that repository. And you do this with the git add command. So what git add does is it creates what's called a snapshot of the files and prepares them to be revisioned by Git. Files in this state are said to be staged for inclusion in the repository. You've basically told Git that, like, yep, I want you to monitor this file. It'll begin paying some attention to it. But we'll see in the next slide that but they're not really in the repository. They're not under full version control quite yet. One of the interesting things to note is that after you do your initial git add, it takes, again, a snapshot of the file. If you make additional changes to the file, they won't necessarily be included just yet in the repository. So here's an example of how you can add a file to a Git repository. First, you got to create the file, and I'll do that with the simple echo command to create a hello.txt file that contains the text hello git. That file exists, and I'll say git add to add it to the Git repository that I'm currently in. While you're working with your Git repository, you can use the git status command, that should be git, to display the files that have been staged for inclusion in the repository. Git status also gives you a list of the files that have not been ignored that are not yet under version control. This way you can find files that need to be added, or files that ought to be ignored. And the way you do that is that you put a description of the file in a hidden file called .gitignore, which is consulted by Git to determine patterns of files that are maybe binary files or log files, things that you don't necessarily want to put under version control. This way Git won't attempt to add them to the repository and won't bother you with them in the git status command. Going back to our example, in the previous slide we added hello.txt to the Git repository, and when you say git status, it tells you a couple of things. It talks about that you're on the main branch, that you've done the initial commit. And then it tells you new file. So there's been a new file that has been staged for inclusion in the Git repository called hello.txt. This command is also nice enough to tell you that if you want to unstage the file, you can use the git rm-cache and then give it the name of the file. So it's really quite helpful in terms of helping you get started with Git. There are a couple of important configuration settings that I recommend that you set when you start working with Git. As you do things with the Git repository, you need to tell Git, well, who are you? How are you identified? So that when people look at the history, they know who made what changes. And so if you issue the git config global user.name and then give your name, this will configure some information in Git, and so then automatically as you make commits, as you make changes to the repository, they will be attributed to you, which is ultimately what you want. You want to be able to identify who made what changes when. Once the files have been staged and you're ready to put them fully into the Git repository, use the git commit command. What git commit does is it creates a new version of the repository that contains, well, everything that was in there, plus the changes that you've made in the that you had staged. They're in those latest snapshots. Git commit supports a -m option for a message, and this is an optional message that you can provide that describes the changes. You should always include a message of some sort explaining why it is you made the change that you did. So when you issue git commit -m and then with a simple message like added simple hello file, command prints out some information. It tells you that it created a new revision of the repository and echoes back the message that you sent, and also gives you a summary of the changes that you made. It says it's changed one file and that there was one line inserted because hello.txt contains one line, and then provides the name of the file, tells you create mode. That's nice. But the whole idea here is that you've now made a change to your Git repository, and the git command is giving you a little information about it. Returning to Git status, after you make another change to your file that's already under revision control, Git status will tell you that. So we add a second line to hello.txt. What do you think? And then when we issue Git status, it'll tell you once again that hello.txt has been modified. I guess previously it told you that it was added. Now it's modified within the repository. Now this change hasn't been staged yet, and so what you can do is then do a git add to stage this particular change, or you can just commit it directly. Since it's already under version control, Git already knows about it, and so then if you just commit the change again, saying git commit, and then with a message like modified file, the git command will tell you that it created a new revision and that one file was changed with one line inserted. The git log command gives you the history of all of the changes in the repository, or if you give it a name of file, it'll give you the history of changes to that particular file. This history information includes information about who made the change and when the change was made, and then also the message that was provided in the commit. So if I run git log on my repository, changes go chronologically backwards in time, so the latest change is at the top. It tells you, first of all, commit, and then like a big old number, which we'll talk about in a moment, but that's basically the identifier of that particular change revision. Then it tells you who made the change. Again, that was based on those configuration settings that you provided. And then also the date that it was changed, and then provides the comment. And then below, there was the next oldest revision there, which was the initial check-in of the hello.txt file. But this is really useful, especially if you have effective and useful commit messages. You can understand how your code has changed over time. Now, we saw that big old hexadecimal number, and I want to spend a couple of slides talking about what that is all about. So when you commit a change to a repository, a new revision of that repository is created, and there is this hash associated with it. So essentially what it is it's a SHA-1 hash code of the entire contents of the repository at that revision. And this essentially uniquely identifies that revision within the repository. This is a really great improvement over some of Git's predecessors. that attempted to create a different kind of more like sequential commit identifier or revision identifier for a revision. Things got really complicated really quickly, especially when you branched. Even though the hash code is kind of meaningless, it's at least unique. And so you can figure out the contents of a repository at a given point in time using that. When we talk about the hash for a particular repository revision, we usually identify it using the first 7 digits of it, the hash, which are unique enough with respect to each other. And so you'll see this in a number of places, both in the Git command line tool and then when we see GitHub uses it there a lot. So in the slide deck, I depict Git repositories as kind of a timeline of revisions. And so I have an arrow pointing to the right to indicate that time is going chronologically to the right. And here I have a little tick marks that indicate the commits to the repository, the changes that are made. And here each one has a hash associated with it. Again, this is the first 7 digits of it. And here again, these aren't necessarily sensical in any sort of order with respect to each other, but you know they're unique. And this is how you identify a particular revision of the repository. Another valuable command is called git blame. And blame probably isn't a very happy word for it. I think I've seen it also called like git laud. Because what it does is it tells you, hey, for each line of the file, what was the last commit that was made to that line? And it basically tells you, hey, whose fault is this? Ha ha ha. It's like, hey, who made that change and what was the information about it? So if you issue git blame hello.txt, you'll see that it lists each line of the file, and so you can see the contents of the file over on the right with like the 1 and the 2. And then prefixes it with the 7 digits of the, or at least the beginning of the hash, and then who made the change and when they made it. I took the timestamp out of the slide just so it would be a little easier to read, but you can imagine what's there. This is really helpful when you're looking at a file and you want to understand who changed things on a line-by-line basis and what their motivation was for doing so. Now, a very common use case in software development is having multiple changes happening concurrently. Most likely, you've got multiple developers who are each looking to add a new feature, and because they're pair programming, they do it independently. Or you've got one person that maybe starts a bug fix while they're also working on something else. You always need to worry about having too much work in progress, but it's just the reality of things. To help support this use case, a Git repository may contain what are called multiple branches within the repository, and each has its own history of changes. You can create a new branch and then make changes on that branch that are isolated from the changes on any other branch. Branches all have a common ancestry. They'll have different common ancestries, but the whole idea is that at some point you create a new branch and work on that. The branches very often diverge, so someone goes off and works on their own for a little while, and then requests to have those changes merged back into the main branch or a branch that somebody else shares. The primary branch in many Git repositories is called main. This is just the current convention. There was a previous convention that you'll probably come across where the name of the primary branch was called master, and this has fallen out of favor for obvious reasons. Master is not the right word here, and it's just not a good word to use. Older versions of Git will still assume the master branch name, so when you are creating a new repository, if you want the default branch to be called main, issue a command like git config -global init.default branch, and then as main. In our course and in GitHub, main is now the default branch for Git repositories. Now, when you create a branch, you specify the particular version that you want to create a branch from. Usually you create a branch, or maybe by default, you create a branch from the latest revision to a repository, but it's possible to pick and choose any repository revision and create a branch from that. You create branches with the git branch command, and you provide that command the name of the branch that you want to create. Git branch will create the branch, and then git checkout will switch the current checkout to point to that branch. When working with Git, the current revision of your repository that you're working with is referred to as the head version. And so when you do a Git checkout, it basically switches the head to refer to the revision on the branch. So as an example, let's create a new branch from our repository called Spanish. And on this branch, we're going to localize our hello.txt to have some Spanish language words in it. And we do that with the following. We say git branch Spanish. That will create a new branch called Spanish. It's there in the repository, but we're not currently working with it. We begin currently working with it by saying git checkout Spanish. And then when we issue the git branch command with no arguments after it, it'll print out all of the available branches, and there'll be a star next to the one that we're currently using. So this is how you can double check that you're on the right branch. Once you're on a branch, you can start making changes to the files and commit them. And as I've depicted here, those commits happen on the branch, not on the main branch that others might be contributing to. And this is nice because it gives you isolation, right? You can make your changes without having to worry about it impacting anybody else. And I suppose you can also ignore other people's changes for a little while you're focusing on your own ones. So I've now gone and locally changed the contents of my hello.txt to have a slash, and then I've translated the English on the left to the Spanish on the right. And now I'm ready to commit it. And so I just use git commit again, and I have a message of translated to Spanish. It'll create a new revision in the repository with that message. And it'll tell me that I changed one file, I added 2 lines and deleted 2 lines because I changed 2 lines. Now, many branches, if not most, have a limited lifespan. Right? You want to be on a branch for a little while you accomplish a particular task. You're adding a new feature, you're translating things to Spanish. Once you've made your changes on your own branch, you'll want to contribute them back to the main branch or some other primary branch that other people are working on so that they can take advantage of your changes and share them with others. You share changes from one branch to another branch using the git merge command. And what it does is it integrates changes from the branch that you're currently on into another branch. And this is one of the great things about Git. Git is smart enough to merge the code and create a new revision that contains both the old changes and the new changes. And most things get weaved together, really quite nicely. So as I depict there, you had a Spanish branch that was created from the main branch. There were some people that were making changes to main. There are some people that are making changes to Spanish. And when you do the merge, it takes all the changes that were on Spanish, merges them into the main branch, merges them with all those changes that were on main, creates a new revision, which is called the merge commit, that has all of the changes combined. As I said, Git is really smart about reconciling changes that happen on multiple branches, but sometimes there are some changes that just can't be reconciled automatically. Git's really smart and tries to do the right thing, but there are some code changes that they just don't know how to, that you can't merge without really being the developer and understanding the changes that happen on both branches. So for instance, if the same line of code has been changed on both branches since the last merge, those changes are said to be in conflict. So here, I have an example of, in addition to my Spanish branch, someone also created a French branch and translated the same code into French, but we modified the same line. So on the Spanish branch, there's a Spanish translation on that line. On the French branch, there's a French translation on that line. The Spanish branch was merged first, so it went back to main, assuming that no one else had changed that same line. There's no conflict, no problem. Git does the right thing. But when the French branch is merged into the main branch, git merge will detect a conflict because there have been 2 changes to the same line in multiple commits, and it doesn't know what to do, which is completely reasonable. I think there are some things that you want Git to do automatically, and then there are other times where you don't want it to guess. You want to flag it as, here's a problem, hey human, please go resolve it. So what happens when Git gets a conflict? Well, what it does is it takes the code from both branches. So both the main branch that you were looking to merge into, and then also the French branch that you were merging, and basically puts them both into the file and says, "Hey, again, hey human, go fix this." And it uses this kind of interesting syntax that really grabs your attention. While the conflicting code is in there, Git will not allow you to merge it. You have to resolve the conflict. You have to get it to a point where you determine, yes, this is the code I really want in there after the merge. And so here's how that happens. So right now we're working on our main branch, and we can tell that because we did git branch, and the asterisk was next to main. And we want to merge French into main by saying git merge French. And it attempts to do so and it detects a conflict because because that one line saying hello Git, and actually both of the lines in the file are in conflict because there have been a change and two revisions on main since the branch was originally created. And so if you look at the contents of hello.txt, you see this kind of unique and glaring syntax where you have a bunch of less than symbols, so pointing to the left, saying, "Hey, the head revision contained this," and so is the Spanish, and then it has a bunch of equal signs that said, "Aha, you were trying to merge in a bunch of stuff from the French branch, and here's what it was. Please go and fix it." Now, sometimes you can have a lot of conflicts in files, especially if you have a long-lived branch, and as you'll see, that we haven't been bringing in changes from main consistently. So if you end up with a lot of conflicts in your merges, then you can run git status, and it will tell you all of the files that have conflicts that need to be resolved. In this case, it's pretty straightforward because there's only one file involved here. But if you've got merge conflicts, again, git status will tell you exactly what they are. Once you have manually resolved the conflicts, and here again, I just did that here. As you can see, the contents of hello.txt now contains both the Spanish and the French translations, and you're happy with it. You can stage the now modified hello.txt file for inclusion in the next commit, and do the commit. This will create a new revision in the repository with the resolved conflicts. Note that because of the way that we've merged things, if you do a git log, you'll see commits from both the main and the French branches, which is probably a good thing. I don't know. I like having lots of stuff in my commit history. Helps me understand all the changes that were made. So branches are really powerful and allow people to work in isolation. But the longer you work in isolation, the more likely it is that other people will be making changes that will conflict with yours. So it's a good practice to merge changes from parent branches early and often, as soon as possible after they are made. This allows you to work with the conflicts. It will detect conflicts early and then resolve them while the changes that cause the conflicts are still relatively fresh in people's minds. One of the things that I've experienced the hard way is having to go back and try to remember why I made a change, 6 hours, 6 days, 6 weeks, 6 months ago. It's hard to get all that context back in your head to know exactly how we should resolve a conflict or why that conflict exists in the first place. And by the way, just because a code isn't in conflict doesn't mean that things haven't been broken. So, for instance, one of the things that I've experienced many times is that someone has renamed a method that I call on a different branch, and I get those changes on that branch, and all of a sudden my code doesn't compile because I had made a call to that code on my branch that doesn't yet exist in main. And so when they did the rename, well, my call wasn't there to rename. And so then it's good to know sooner rather than later that someone's change has inadvertently broken your code on your branch. Again, because the longer that you wait to merge almost always increases the overall cost of maintaining the code. One thing that's popular for people to do is to create something called an integration branch, which allows you to again, experiment with the merging on its own branch before ultimately integrating it back into the main branch. But as you can see, things can get pretty complicated because what you end up with is multiple branches, and you've got revisions and changes flowing from one branch to another. Luckily, Git does an excellent job of the bookkeeping, and it makes sure that you know what has and has not been merged. So even though this is pretty complicated, I think we have the best tools we've ever had for doing this kind of very complex code flow. So this is something I want to reiterate. I think is a very important concept in software development, and that is making a case for having short-lived branches. So as I've said, the longer that you wait to merge and resolve conflicts, the more confusing, the more overwhelming it can get. I remember working on a project one time where we had two teams that were working independently for something like 6 months. And then each one of them finally got all their stuff working, and they were like, great, we're almost done. Okay, time to merge in. And it took us another 6 weeks to resolve all the conflicts, to get everything working again. And for me, it was just a really good professional lesson in the importance of making sure you don't go too long without sharing your code with others. Because the more changes that you make, the harder it is to integrate all those many changes made over many weeks and many months with all the other changes that have gone in also. So my advice to you is that don't wait until you think you're all done and everything is perfect before sharing your code. Instead, make small changes, make sure those small changes are solid, and then share them with others so that your changes are in the system, and that way makes it easier to identify any bugs that you've integrated inadvertently. It's always better to find the bugs early than it is to find a bug that you introduced weeks ago, weeks later. So merging frequently gives you quicker feedback on your code, and this leads to a practice called trunk-based development. Trunk here refers to always working on the main branch, the trunk of the tree, essentially. So the branches don't live for very long. You make a change, and then a day or less later, integrate it for everybody else to use. Again, this lets them use your code to test your code to make sure that it's solid, that it does everything that you expect it to. Now that being said, one of the concerns people express about trunk-based development is like, well, the feature isn't done yet, and so the user shouldn't see it, and that's true, right? If you've got something that's not yet working all the way, or something that you're not ready to release to your customers, should you introduce those changes into the system? I would say that almost always the answer is yes. And one of the things you can do is you can have the code to implement a feature, but you don't necessarily need to show it to the user. You can use something called a feature flag, which is a little configuration setting that will disable the user seeing or experiencing your changes until you're ready for that. I think this is a great compromise that again allows your code to be there, being used potentially, or at least in the system so people can see it, without it impacting the end user's experience. Trunk-based development also provides a nice alternative to what's called Git flow, which is a way of using Git and having long-lived feature branches or longer-lived feature branches, and then merging things in at the appropriate time. There are lots of people that like Git flow and have found success with it. I've tried it; it works okay, but again, I always worry that I'm waiting too long before sharing my work with others, and that then makes my life and everybody else's lives harder further down the line. Branching and merging is one of the more advanced concepts in Git and in source code management, and Git does a great job of it. Beyond what I've talked about here, there are some other tools that it provides. I'm not going to go into too much detail here because I don't think it doesn't make sense for the introductory content, but it's things that you might come across in your travels. There's something called Git rebase, which is actually quite popular. A lot of people use it. It's an alternative strategy for merging code from one branch into another. The thing that rebase does that I think people like so much is that it doesn't create all those merge commits. So when I merge that French branch into my main, all of the commits that were made on the French branch will appear on the main. And if you've made lots and lots of commits, or maybe if your commit messages aren't that great, that can really clutter up things in the main branch. And I understand that. And so then lots of people like to use Git rebase, which basically rewrites the history, reapplies all of the changes that were made to the branch to the main branch as things are merged. Another alternative to Git rebase is when you commit as part of the merging, you can use the -- squash option that will basically squash all the commits, take all the commits on the branch and merge them in as a single commit, not as a series of commits followed by a merge commit. Again, this is something that GitHub does. And again, if you have a long-lived feature branch with lots of changes, yes, I agree that it's probably better to have one concise commit message that describes all of the changes. But these are kind of advanced, and I think if you're not careful, you can get your repository into a bad state. So I recommend that you get some experience in the kiddie pool using just plain old merge, and then at a point where you feel very comfortable with that, then it'll be a good time to start looking at Git rebase and squashing your merges. Well, I think we've reached a good stopping point. Whether this content was brand new to you or if you've used version control in your other classes, I hope you enjoyed this overview of the essential concepts of source code management and learned how the Git tool can keep track of changes to a codebase that has multiple contributors. In the second part of this slide deck, we'll talk about how Git and GitHub work together to provide distributed source code management as part of the joy of coding at Portland State University.